we'll go over who we are first, and then we'll get into more details of how everything works and what we have. So first of all, this is me, Shai Elmog, and that's my partner, Chen Fishbein. And a little bit about us. For the past 20 years, 20 plus years, I've been programming professionally. Past 14 years, I've run a consulting company and worked mostly with Sun, Oracle later on, and with practically every operator and manufacturer of any, pretty much all scales, names you might have known, like Vodafone, Verizon, Sprint. Worked a lot with Docomo, original device, Java-based devices that they produced. I worked on that project as well as other projects with those guys. Member of the original Wireless Toolkit team. Very important member, by the way. There's a guy. Inside joke. And also, besides that, what did I say? Yeah, never mind. Latest thing that we've been working on was Luit, which Chen actually developed, and I joined him. And I'll let Chen introduce himself, and then we'll go back to Codename One.
Hello, everyone. My name is Chen Fishbein. Used to work for Sun Microsystem, now Oracle, for the past 8 years or so, 7, 8 years. During my time at Sun, usually mainly focused on mobile tools. I tech-led the Sprint Wireless Toolkit, and for the past 4 years or so, I founded Luit and developed most of it with Shai.
Okay, so that's briefly who we are. But let's talk a bit about the problem, because I find it's the most interesting way of describing the solution. Well, there's Java. We all program Java. I'm assuming that's pretty much a prerequisite for this room, that you be familiar with Java. So what is the state of Java on devices? There's a form of Java for Android which is pretty good. Actually, I'm all for having Java on as many devices as possible, but it's a different type of Java. It's not quite the standard Java. You need to use the Android emulator. You need to use Android toolchains, which are good on their own, but it's within Android. Now, the device fragmentation on Android, in my opinion, is a bit exaggerated. There is a problem, but it's relatively minor, especially compared to the history here. However, newer devices are starting to actually create a problem there, especially with things like Kindle, Fire, and devices like the Nook, with things, they don't have the Android market, and then things start becoming a problem. And then real fragmentation starts forming. But if that was the problem, that wouldn't be a big deal. There's Blackberry, which has a form of Java. It is a form of Java, but it's something, it's J2ME, which is Java 1.4. It's got all sorts of limitations. Its version of J2ME isn't very good. Its own API is completely invented of its own, and it's one of the most, I'd say, frustrating platforms to develop to. Even though it's Java, supposedly, it's obviously a problem. But those are the good guys. These guys support Java. The other side, now those are those horrible, horrible individuals that don't support Java. I mean, how can someone do something so nasty? So the guys with iOS, iPhone, iPad, desirable devices, obviously. There's Windows Phone, not so much, but Windows Tablet, RT, stuff like that. Well, Microsoft is a juggernaut eventually, so they'll do something. And it's a valuable and growing platform in that regard. And we want to get into those as well. So we don't really have any choice when we're looking at that. We can develop for Android, that's great, but then we're locked in the Android garden, which might be wonderful. But it's that. And as Java developers, we can't truly get the value of write once, run anywhere, which we've always had, which is one of the main things we've always seen with Java. Well, didn't really is the right term here, because we guys looked at it and we said, that doesn't suit it. We can solve that particular problem, and we believe we have solved it. And the way we solved it is the way that Java always solved this particular problem, the way it solved it in the desktop. We just did pretty much the exact same thing as Java did in the desktop, which is build the entire stack for the developers. and we added some modern approaches that are more appropriate for mobile device programming that weren't available when the original Java came out. So we reimagined, I shall say, Java as it is, as we always used it, for the mobile platform. And we did that by leveraging open source. Our entire product line is effectively open source. And we made it free, because Luet, by the way, which we developed, is entirely open source as well. And we like doing that, and we got contributions from people, and we've got a major community. So we just took that spirit, that community, that sort of development approach, and we merged it into Codename One. Now, what is it really? We'll start, demo is the next slide, so I believe in showing, first of all. But I want to say something about native applications first, so you'll have some context of what we're talking about. We allow you to develop native applications. When I say native application, I'm not saying like the PhoneGap guys say they're native applications. Yeah, right. You just package the HTML into an application. It's not a native application. It's an HTML packaged into a local executable. Great. When we're talking native applications, we actually mean you can define a native interface and invoke code in Objective-C and embed the result directly into your code. In Objective-C, obviously, when running on the iPhone. In C# when running on Windows Phone. In Dalvik when running on the Android. And I know technically when you embed Dalvik, it's not really native. We use the word native here to describe the proper language of the platform, not to describe C. So Dalvik for us, the Java that's on Android proper, is what we define as native here. So you can access all the abilities of the device. And that's the important thing, and that's what we term as native. So without further ado, let's show you what we can do with these sort of devices. So I'm going to do the classic mistake of actually showing you things live and not recorded demos. And as you can see, I'm presenting this entire thing right from my iPad. It got wiped yesterday night because Apple chose it as the perfect time to send in an update, by the way. So if something fails, that's because I installed everything this morning and from latest builds and everything. As you can see, we've got all sorts of animations and stuff like that that you'd expect in a modern application.
What is
You're correct. I'm running ahead all the time. I need Chen to ground me here. This is generally a demo of how what sort of applications you can build in terms of UI. Now, this is a relatively simple kitchen sink demo. We keep it simple and don't show too much here, mostly because we want to not use the network or anything like that. See, it was wiped, so email doesn't work now. That's great. As you can see, everything can adapt on the fly to the theme of the device and provide also very rich. You don't really see it in the projector. This theme is very rich in terms of its looks, very textured. It's got all sorts of shadows and stuff. It doesn't really properly pass through the projection here. But as you can see, we can also show video embedded in place and similar complex things, like, for instance, let's say cheese, everyone. Okay, damn camera. That's awful. I'm sorry, you all didn't come out right. But anyway, let's try making something that's really meta. Let's show a demo within a demo. So Chen now is taking other devices, and he's going to show you those actual devices running through our other demo, showing the exact same demo. Now, notice that here, running on the Android device.
Maybe you can turn it so that we can see directly.
Sorry. Thank you. So now, as you can see, when running on the Android device, because the device is not a tablet, he has the UI is multi-screen, unlike the single-screen UI you had on the tablet. And even more importantly, the UI adapts to the conventions of the Android 4 in this particular case. like he doesn't have a back button. You notice the scroll acts and the way that it acts in Android. The title bar looks like it does in Android. All sorts of things like that lots of small adaptations. Now, let's
By
show.
the way, this is a Samsung Galaxy.
That was lovely. I think that's why I said live demo, not a great idea. Anyway.
So that was the
Samsung Galaxy S.
Right.
Let's show. That's a Nexus One. Yeah? Same thing, only gingerbread device. Slightly different UI. Okay, we can move forward. Let's show iPod Touch. Now here, notice again, it's an iPhone similar to this, but obviously here it has that back button that you're familiar with in the iPhone. Chen isn't used to using one iPhone. Here we have a Blackberry, obviously the coolest device in the world. It's a very compelling device. It's got touch. And here is one of my absolute favorites, the device that, when it turns itself into a screensaver, loses its network connection. I kid you not. This is real. This is entirely real. This device is going to take over the world with that functionality. But as you can see, that's the actual button design. That's not something we've invented. And this is a Series 40 device, actually cooler, amazingly, than that Windows Phone device. An actual Series 40 device, has 4 megabytes of heap. I'm not joking about that. It has 4 megabytes of RAM. And it works rather well in terms of performance and the things it can do. So without further ado, I'm going to use the most elaborate system of transferring to the actual how we done it demo portion of everything. So the thing is, up until now, I showed you, okay, what we can build in very high level. Obviously, we can build a lot more than just a few things flying around. Chen is going to show you how we did it. So here's that specific demo that we saw earlier, the kitchen sink. Chen is running it in our standard skin.
This is NetBeans.
That's right. He's running it in NetBeans specifically. We support NetBeans and Eclipse. As ex-Sun guys, we're used to NetBeans, so we work with it. It's a habit. I think it's also good, but specifically pick whichever. As you can see, this is the exact same demo. And by the way, he's running on Windows, and you notice that he's using an iPhone. I don't know if you know how to develop to Apple. You must have an Apple machine. You can't develop for iPhone without a Mac. But here he has an iPhone skin, an iPhone simulator, iPhone native look, running on his PC. Maybe you can show us Android development? How hard would it be? Very hard to switch to the Android. Okay. Yeah, you almost got it wrong. You selected the wrong entry for a second there for it. Now, as you can see, you can have it in a full-size mode, or you can move to rotate it as well, or you can move to a scaling mode, which is sometimes more convenient to have the skin scaled. You get some drawing artifacts, but you can then work on a smaller resolution display. You don't need, for instance, for the iPhone 4, you don't need to have to buy a special monitor just to see the whole screen. It's helpful sometimes when you're on a trip and you don't want to carry this around. So anyway, this is running on the Nexus here, and maybe we should step into the debugger, show some of that. Now, the kitchen sink demo is something we hand-coded because we wanted to show sometimes developers prefer to hand-code, sometimes they prefer to use a GUI builder. We have both. We support both. Both are great. This specifically we did by hand to show you how it's done, to let the more coders within you do that. We'll later show you how to create with the GUI builder. Same thing. So here's that exact same demo running. Now, And here's a breakpoint. And as you can see, the code is really simple. It just adds an action listener. If you're used to swing, AWT, all of that stuff, he's got a breakpoint, standard breakpoint that you would get when working with JavaSC. Notice the debugger is the debugger you get from JavaSC, not some special form for J2ME or stuff like that. You can inspect everything. You can see everything. Live, can you change skins to iPhone or something else? The Nexus skin is just huge. Anyway, so, and live you can change the skins while still debugging in the background. It's amazing, absolutely. Now, what's next? We move to, yeah, great. Kind of helps me here with the memory thing. It's senile. Anyway, we're creating a new project. Thank you, Chen. And here we'll create a GUI builder project, where we define the project name, where it is, all of that sort of thing. Just give it a name. And we'll just create something at the level of, yeah, that works. You should have done 12, actually, there. Yeah. It was a good year, but for JavaOne, so-and-so. Actually, this one's better in terms of... I can tell you one thing, it's better to come as a non-Sun employee to non-Oracle employee to JavaOne, because we get the tickets to the show. They literally didn't give us tickets last year. Yeah, food as well. They don't give you food. You starve. Anyway. So this is the project that we generate, a GUI builder project. And as you'll notice, there are 4 files here. There's the theme file, which contains all the resources we have. You can also insert resources into the jar if you want to, although there's a big benefit in having the resource file. It contains the actual theme, CSS-like environment. As you can see, you've got here, can you reduce the size of the themes area? So we can see, yeah, great. Where you can have actually the selectors, the data that you have, it's entirely visual. And what you see on the right, here you can actually customize the look of everything. And what you see on the right is a live preview of the application that we've created, actually showing. You can actually see the application running here. And when you make changes in here, you see this is CSS-like in its essence. It's more powerful in some regards, where we have 9-piece borders and other things like that you don't normally get in mobile CSS at least. And as you can see, Chen is making changes right here, and you can instantly see them in the running application. Now, you can also open a simulator directly from here without compiling or doing any other such process, and instantly see the changes. You can also run a device with a special application that we've built for this, and see everything changing live on a device while you're building your application right here. So that's the theme portion here. Let's show how the GUI is actually built with the GUI builder portion. So in the GUI builder portion, you can actually drag components into place. Now, technically later on, you'll wire them together with Swing-like code. So let's just, yeah, great, a button, and let's call it something, JavaOne, or whatever. And it's all pretty standard stuff, GUI builder, that you'd expect to get. With layout managers and everything, that's standard with Swing AWT. We improved on that a bit, by the way. Sadly not enough, but we're improving. And there's an event tabs there. We can bind the listener directly to the button. Now, here, because the IDE, because the binding goes through the GUI builder, won't see the whole add action listener thing, but we will see the actual callback method here, and Chen can just show a dialog here or do something like that. Now, I apologize, this is a relatively simple application, but given the time constraints, like I said, come tomorrow at 10 to the tutorial. We'll show you a bit more of an elaborate demo. It takes an hour and, I think, an hour and 20 minutes to just read through the demo, so that will be fun. And that's it. That's a simple dialogue. You can get hello JavaOne, everything, okay, cancel, and just let's run it. And it works on the simulator instantly. You can debug it. Obviously, everything just works. Now, what do we do with that? That's great on the simulator. We want to get it onto the device. So that's actually the easy step. Chen just right-click on the project, and he can right-click. Yeah. And he can send a build for every one of the platforms here. And here he's sending a build for, someone didn't define a certificate. Yeah, it's a new computer, by the way, he just got it. So among all the things of losing the iPad, we also had an issue of installing a new computer. So Chen can literally send a build for every one of these platforms. And he's got a bit of an old version that doesn't yet include the Windows Phone that's just launching now. And once he sends it, that build goes to our cloud servers, which I'm going to talk about, that do the translation to the native code. Now, why do we need cloud servers here? Why not just compile everything locally? Because locally you'd need a Mac. And we have physical Macs in the cloud to build the iPhone version. We have physical Windows machines in the cloud to build the Windows Phone 7 and the Blackberry versions. And that's important because you need to install like 20 different things just to get everything working properly, and you need 2 physically different machines to get everything working. So yes, you can go to our source code repository, download everything, go through that whole set of huge steps, obfuscating and doing everything just to build that native application, or you can just right-click and send a build for free. We don't send the source code. I want to stress that portion. We send just the compiled binary data. Now,
over HTTPS?
Over secure HTTPS, obviously, I'd say it goes without saying, but it should be said. Now, this is the result of a build. You can actually get the APK, download it, and upload it to the App Store. It would be a release version if it has a certificate. The cool thing about this is that every one of you can just pull out your device and point it there and install it on the device. So like, I'm expecting to see it like a show, you know, like in a concert where everyone lifts up their devices and scans the QR codes. I'm going to give you a minute to QR me. Androids? What, everyone has an iPhone? Thank you. One guy with Android in the entire crowd. Right, so you can point literally your QR code and install the application directly onto that. It's an impressive application. You'll get tons of use from it, as you can see. But for something that you built in like 2 minutes without installing anything, you just install one thing, our plugin, it's pretty cool. And it just works out of the box. You don't need to do too much about it. And it's in Java. Too far away. We had our doubts if it will work. There's one. Yeah. Anyway, so that's really convenient. You can obviously download it and pass it through a cable. You can also press that small email button to instantly send it directly to your email. Lots of convenience sort of things there in order to build the actual native application. Now, we're going back to the slides, right? Great. So let's explain a bit more what we saw there, because I was running through things pretty fast and mentioned the cloud server and mentioned the stuff there, and I'm sure there will be questions later, and I'm going to try and leave as much time for those questions as well. So just briefly, this is generally the parts that consist of Codename One. Now, one of the reasons we called it Codename One was because when we started with that, we needed a temporary code name. So why not find one? And then we thought, you know, after you find the name, you search for a meaning for it. So we found a meaning for it. We take these separate pieces and make them into one whole thing. And we did take separate pieces. Some of them we wrote, some of them open source communities wrote, and we unified them into a single solution for all of us. And the separate basic pieces are obviously the API. Like you saw in the terms of the UI, it's more Swing-like, but it's a whole stack of API. Networking, storage, cameras, everything you need. And it's all integrated together. That means things like observable streams. So your buffered input stream is actually observable, and the progress indicator in the GUI automatically binds to it if you wanted to. That's the type of thing that we can do when we truly control the platform to that level. There's the GUI builder, the designer, that allows you to visually build the applications. There's a simulator that allows you to work with that. And all of that arrives to you through plugins. We currently support 2 major IDE platforms. I talked today with JetBrains guys. We'd love to support them too. It's just obviously a lot more resources as well. But generally, you just install the update center for our plugins. Works. That's pretty much it. Now, this is the interesting part. The build server allows you to just install that plugin, to not have to deal with all the additional steps. Should you deal? You can if you want to. If you want that extra security, you can do that. We think the value of having a build server rather than actually going through all of the steps to every one of the platforms in the maintenance in the long term is huge. The build server also lets you get back the source code of the application. If you're a paid subscriber, by the way, payments like $9 a month. If you take the unlimited version, it's free with a free quota for everyone else because, like I said, we're an open source project. So we try to be as free as possible. And there's a cloud server that allows you things like analytics and stuff like that that are really difficult to implement without actually building server code. So we built that server code in a generic way, and we just let you interface to it. You don't need to if you don't want to. And that's a major point there. Now, this is just a subset of some of the features we have. Whatever you don't see here, we probably implemented to some degree. Things like SQL aren't even mentioned there, so we've implemented that as well, and all sorts of other things. It's very complete. And if taking a picture, then this is probably the slide to take a picture of, because these are the resources you can turn to. Now, our documentation, I don't want to make it seem, it sucks. I worked on it a lot. We worked on it quite a bit. It's more than 100 pages of documentations, plus tutorials and videos and everything. As you can see, we did a lot of effort here. We built quite a lot. It takes years to properly document and build something like that with all the tutorials, all the paths, everything. We can't possibly do that within the short amount of time that we've actually been on this thing alone. So that is why we spend an extraordinary amount of time in the discussion forum trying to personally help everyone there. I literally lurch there all the time. You can actually see my name on half the posts there. Where am I kidding? 90% of the posts there. And that's what we're trying to achieve. We're trying to help you as a community to actually build something, whether you choose to use our cloud server, whether you choose to work on your own, in whichever way. We're trying to help as much as we can because we believe in the value of the community here. So feel free to ask questions, criticize, or anything like that over there. And feel free to start with it right now. I'll go back to the previous slide, which is valuable, but we're open for questions as of now. Yeah.
Now that I have that APK file from the QR code, can I put it in the Google Play Store and make some money on there?
I'm sure it'll be an instant hit. That one specifically, no, because Chen didn't include the certificate there. So there goes the fortune. But if it includes, yeah, you can. We take no royalties, nothing. There is, I'd like to say one small thing. We do install a small callback to our server on the first install just to track that. There's an opt-out. You can just add a switch to the build and not give us that information. Since we'd like to just know how many people are using applications based on that, we'd appreciate if you don't do that. But because we're open source, we feel that we must allow you that transparency.
I think I spaced out for a minute and didn't hear.
Yeah.
When I send something to your server so that you can Macify it,
yeah.
Does that cost money? If so, how much?
Okay. We have a free quota every month for everyone. It resets at the end of every month. So you get 100 build credits. That means up to 100 builds of practically any platform, except for iOS, where it's up to where you burn 20 credits with every build. Now, there's a reason. It's really, really, really expensive to host a Mac in the cloud. You wouldn't believe it, how much money. There's one company in the world, in Switzerland of all places, really expensive, and so that's why we take more credits from that. But we do allow it. So I know people opened additional accounts and did all sorts of things like that. And also just wait for the next month, worst case scenario. So beyond that, it's $9 per month for the unlimited. We don't make money off that. For us, it's just covering basic costs. Yes. I didn't hear that.
The Android certificate, I assume, part of your plugin sends your personal certificate up.
Yeah. Yeah.
How do you handle that with Macintosh if you're on like a PC running this and you don't even have the signing certificates?
Okay. Good question. Good question. For the iPhone, you need specific iPhone certificates. So the certificates are something that's generated one time. You don't need to generate them for every build. You don't need to generate them for every application. You just do this one time. You do need a Mac for that step. We usually point guys to Mac in the cloud, where they can even log in to a remote Mac. Do this one set of steps once. Get the two certificates that they need, debug and production certificates. Use them. The rest of the things, provisioning profiles, stuff like that, you can do through the web interface. You do need a Mac again to upload to the iTunes store. Those of you who didn't try that, apparently uploading through the web isn't good enough for Apple. So once you have your application complete, you'll need a Mac again to do that. But obviously, you don't do that every day. And you can do your maintenance and development through that. And you can use Macs through the cloud just like that. So we want to simplify and automate that as well, by the way, in the long run. Obviously, we've taken up quite a lot of challenge on the way. You wanted to say something?
Yes, in the plugin, you point for those certificates, and then
Yeah.
you know how to do it.
Yeah, in the plugin, there is a setting there. You want to show them maybe that? While there you go. Yeah. Do we support what? No, we don't support OpenGL, and at the moment we don't really have plans to support OpenGL. That's something that I didn't really mention. We're mostly optimized for applications, not so much for games. So when some people are using us for casual games and study aids, which are more interactive, but our general use cases are applications like media and audio, video, mapping, business applications, obviously, lots of stuff like that. Gaming, which is very 3D oriented and very intensive in terms of graphics. Not so optimized for our higher level APIs at the moment. Since we have so much work to do, we don't have immediate plans to support that. Yeah.
Looking at your website, so what is the archiving and archive limit, basically? If I was to purchase...
It's something that I need to remove from the website. Literally.
Okay. That's good.
There's so much things to do, yeah.
It's great stuff to develop all the mobile applications from one place, but is there any performance issues that we need to know, for example, not using Android, development Android?
Okay. Yeah. Yeah. Well, performance is a loaded question always. We find that performance problems are often cross-platform, just like bugs are often cross-platform. So once you build your application to 2-3 platforms, its performance improves across. We find that most of the performance issues are things like people doing stuff on the UI thread, people not properly assigning things to separate threads, to models, and caching in the proper way. So when you improve performance for one platform, it improves globally. Obviously, there's lots of stuff we can do on our side when optimizing the iPhone code. Today, most of our iPhone code is very hardware accelerated in terms of the UI, but in terms of the VM implementation, it's so-so. Our VM implementation is at the moment very weak. But that doesn't really matter as much because most of the performance bottleneck is the UI. So that we hand-coded in Objective-C and did it very hardware accelerated, so you don't feel it as much. You saw it running on the device. So I'm saying if we can run on J2ME devices rather well, the other ones, I mean, how much megahertz is that Asha thing?
That's a pretty fast gigahertz, actually.
It's a pretty fast gigahertz. What's fast for, what, is it a gigahertz device? Okay. We're running on weaker devices than that as well. It's, by the way, his device. Thank you very much. Thank you so much.
But still, yeah. It's $100 device.
Yeah.
Do you support geolocation or sensor?
Gyro or sensors?
Geolocation.
Geolocation. We support GPS and we support some sensor information. We don't give you the fine-grained sensor at the moment because, like I said, we're less optimized for games. It's something, just an API that we need to do. I'm just generalizing that usually it's used for games. It's not true. It's used for some applications. It's one of those things we need to do. One of the things that I didn't stress enough, we allow calling native code. So you can call Objective-C, call any Dalvik or any other such API, and you can implement that sort of functionality that we're missing. And people have used that in the past to contribute code to us. And we have received quite a few code contributions just right now before coming here. A guy in our community forum just contributed TCP/IP implementation. We, up until now, only supported HTTP and HTTPS. Now we support sockets, apparently. And we didn't write a single line of code. The favorite way of supporting new functionality, in my opinion. I recommend it for everyone. Anyone else? Yeah. Go ahead. No, we're not nearly as good as Java 2D. Java 2D is very refined in terms of its support for vector, all the minute anti-aliasing stuff. And I had a long discussion with the guys in support of JavaFX or things like that. The reason Adobe is failing on iPhone isn't so much that Apple is blocking them from their internal APIs as much as the fact that they need very refined vector graphics control. Now, the thing is that it's really, really hard to do that in a cross-platform way that is actually consistent. So we have some graphics API. You actually have a paint and a graphics, and you can override it, and we have painters, and we have styles, and we have themes, and we have lots of the things, everything that you always wanted to have in Swing, we have it. But our graphics object is much simpler. And most of our functionality is in the higher level components, and in the theming, and in the skinning, and in that ability. And we try to stress more on that level, where we have strong multi-DPI support, strong image border support, that sort of functionality that we find is very performant on all devices, regardless of device family, and very consistent. And that's the huge value there. When you go into subpixel anti-aliasing and the device pixel, the way the pixels are organized internally, the subpixels, I don't know if people are familiar, enough graphic geeks here, it changes when you rotate the device, and doing that in a cross-platform way is technically impossible. So obviously Adobe wasn't successful in doing that in a performant way, and no one can. They came up with Flash before there were phones like that. And I don't want to go into that ditch myself. So we'll improve that support, but it will never be nearly as good as Java 2D, because Java 2D makes a lot of assumptions that can't be made in a performant way. Yeah, you asked previously, so.
What's your adoption rate on the market? How many people have been using your
well, we have tens of thousands of downloads. I can give you the number that we give to investors, but it's really a made-up number. I'm talking to engineers, so, you know, it's one of those. Or I can give you we don't really know, because, like I said, it's a free product. People install it through an update center. We don't have an accurate counter. We know it's in the tens of thousands of downloads. There are thousands of developers registered on our servers, sending builds, working with the system. and the numbers of actual device installs and things like that are crossing the pretty good 6-digit number, which, okay, go ahead again.
My question, which Java VM do you use, and does it support reflection, and do you support JNI also?
Reflection and what else?
Which
JNI.
Java do you use?
Okay. Reflection we don't support. We support class 4 name. We don't support reflection. And technically, if you'll go out to, say, Dalvik in Android, then you'll be able to use that reflection over there. But within our VM environment, you won't be able to do that for the foreseeable future. And the main reason for that is, for instance, on iOS, if we support reflection, we'll have to actually package in the entire VM, and we won't be able to obfuscate and remove, rename, and do all sorts of things. Reflection is great for development tools. It's usable maybe in some cases of EE, and even then they're trying to more move to bytecode and stuff like that, all sorts of processes. For embedded system, for embedding, for small application, you need to be able to remove code, to remove things, to optimize as much as possible, and reflection is a hindrance to performance. So I really don't want to support reflection, and technically, since we want to support additional Java languages on top of this platform, we don't at the moment. We might need some form of something to offer to them. And reflection might be a solution there. Obviously, we'll have to pay that ultimate price of size. So I don't want to commit that we'll never do it. But I'm hoping there'll be another solution at that point that will be more performant and more appropriate for mobile devices. What was the other question? JNI. What we have is the native interfaces. It's not JNI in any way, because we don't call to C. For instance, Windows Phone doesn't have any C layer. On the iPhone, you'd rather have Objective-C rather than C in terms of the call. And in Android, you have C, but you'd usually prefer just Dalvik and doing your stuff over there. That's the more common use case. So we don't support JNI. It's just not available in all places. We support calling to native, and in there you can do the stuff whatever you want. You want to do JNI on Dalvik, that's great, you can. But obviously, we have what's called native interfaces. Native interfaces is an invention of ours, which is a specific interface that derives an interface called native interface. We recognize them on the fly, and we offer you want to show a right-click name? We offer you literally a right-click on the native interface where you can say generate native code, and you will get a source tree with native stubs for every one of the platforms. And you just fill in the blanks. So for Android, you'll get a Java file, but it's a Dalvik file. For iOS, you'll get literally an M file for Objective-C, and for C# or CS file, and so forth. And you just stick your code in there, and you write whatever. Now, it's not native in the sense of JNI being native. We don't get that. On Android, specifically, which does have JNI, you can write JNI. But that's only within that particular code. That means when you write to our VM, you write in our environment, and we sort of sanitize it. So when you're running on Android, you're running on Android's VM, you're running on Dalvik. We don't add a layer there, but we don't let you see it normally. It feels when you're programming on the PC that you're programming to some abstract VM, because you're programming to some commonality we have there. If you want to exit that commonality, you call to the native code, and then you get access to Dalvik. When you're running on iPhone, then we have our own VM, because we don't have a choice. It has a garbage collection, it has all sorts of things, its own set of bugs, but it's generally pretty much similar to that VM. And we try to give you that sort of unified thing. When you're running on RIM, we actually take your code, process it extensively and painfully, and remove all the Java 5 features from it, so it can run directly on the RIM VM. So that we make that seamless for you in our build server. We make all of that effort to strip everything and just give you something that feels like a Java 5 VM, a subset of Java 5, because we want it to be small and efficient still. But you do get things like generics and all of the stuff that you're used to. And you can still program for all the devices. And that's the general idea. And I can get into the technical details further, but I'm getting some yawns, so you can talk to me later, obviously.
There's the big debate in the industry about native versus HTML5. Are you guys interested in, expanding into the HTML5 era, or are you going to pretty much stick to native?
As you noticed, I didn't mention HTML5 almost at all, because people constantly get confused. People turn to us and ask us, you're an HTML5 solution, and it's technically, if HTML5 is able to actually run this, or something that's of the level of J2ME, then we'll target HTML5, but it's not even at the level of J2ME in terms of functionality. Things like threads, on the device I'm talking, things like threads, mutable images. I don't even have mutable images properly. And I can't even use OpenGL there because that doesn't work on the devices. So it's not there yet. I can't target it on the devices because it's not really technically practical. When it will be, hopefully someday when it's actually HTML5, yeah, why not? Well, we can add it. Right now, I do want to add it for demo purposes, so we can actually embed a live demo. Right now, we can take our application, package it as an applet, and let people run it directly through the web. That works. That's pretty easy to build. We don't offer it out of the box mostly because of laziness from me. I need to actually sit down and write code there and contribute. Hint, contribute someone. Anyway, but also one of the other reasons is it's an applet. People hate applets. It's a problem even if it does give you an ability to expose your application. If it's an HTML5, and on the PC, HTML5 is in a much better state than in the mobile, then that's a huge use case, and I'd like to offer that. We obviously support embedding WebKit. That's built in. We have full integration with the native WebKit. So you can, in theory, just embed an HTML5 application directly into our application. Don't do that. It sucks. We don't give you any benefit over, just going with PhoneGap. So if that's what you want to do, that's why you want to use our platform, use PhoneGap, don't use us. Don't say you're using us because we don't want to be associated with bad HTML5 applications. And anyway, so it's obviously, I think I answered the question. Yeah, okay, that's enough. I don't need to. Yeah.
Android is releasing new features frequently. So how are you guys planning to catch up with those features? And are you currently supporting near-field communication, NFC?
NFC. Okay. The speed in which they add features is, well, lots of times people say, they changed UI in such and such way, or that's less frequent. There are new features indeed, like NFC and stuff like that, and mostly features that aren't consistent. For instance, NFC is something that is only on a few devices, so building it in is something, okay, we want to target that specific niche. So no, for instance, NFC is one of the things that we didn't reach. And like I said earlier, TCP/IP was just contributed right now practically. So sockets, that is. We had HTTP, HTTPS, obviously. Sockets is something that just got contributed to. So things are moving along all the time. Because we're open source, because we're essentially a project based like that, people contribute, people can add things, and because you can access native, you can add it yourself. In lots of cases, we just build stuff based on demand from users. For instance, SQL is something we really didn't want to do. It doesn't work on all devices. It's inconsistent between devices. It's problematic in lots of ways, and we generally don't think it belongs on the device. But a customer convinced us. They just spoke with us. They paid us. But that's a special case. There are cases where they didn't pay us, for instance, things like processing and stuff like that. But hint, And we did it. We just built SQL, and it was out, and it took us like a week to do. Yeah. Chen did it, so he's like, hey, it was easy. It was easy for me. So that's just, usually these things are pretty simple to integrate because you're generally interfacing to the device capability. 90% of the problem is UI. And there, because we have an extensible framework, you can often add your own widgets, just like you can in Swing and AWT. Swing didn't have all the widgets that you needed, so you added them. Now, the thing is with Swing, a lot of the times you needed to go deep. And you couldn't because of the long maintenance cycles from Swing and the fact that you needed the JDK installed of that JRE on the user's device to get updated with the new changes from Swing. Here, everything is embedded into the application. So you can make the changes. And if we make the changes, you can instantly get that, and it's in the new version of the application. So all of the problems of provisioning in Swing and all of that pain doesn't exist here. So I think those problems will always exist of some disparity between what exists. But I think we have several different solutions here. We allow you full access for the API. We allow you modularity of the API. And because we're cloud-based, we can instantly deliver new features, and we do constantly. Yeah.
Can you give a small explanation about what's happening in the background? So you send the bytecode,
jar.
So you send the compiled bytecode?
The jar, yeah, the compiled bytecode. Mm-hmm.
What happens on the server? So you read the bytecode?
We read the bytecodes based on the specific platform. For every platform, we do something different. And it's not rocket science. What we do, there's just for Dalvik, for Android, we just compile it together with stubs that just call the code, and we have the libraries, the APIs, and ports for everything to every single platform. It's generally pretty simple, and if you sit down a bit with our API, with our implementation, you can see how it works. It's not that complicated. Most of the heavy lifting is done on the API, where we have the portability layer. That's the big amount of code. And that's the whole layer of the graphics of all the APIs for the compatibilities and all of them pointing to a single porting layer, which we hand port for every platform. And that defines the commonality, the differences, rather than the commonality, between all the platforms and the different behaviors between all the platforms, to create that sort of feel of all the different devices adapting and yet feeling like a single device when you program to them. That's the heavy lifting, and that's pretty easy to see. And the server is just like VM stuff. It's bytecodes, manipulation. It's you need a subscription, man. Yeah. It's something, people do it a lot for most of the platforms, less so for iOS. One of the guys, we as a habit say we don't support you when you build outside of the build server. As a company, not because we don't support it, but because we don't want the maintenance. We think it's a sort of trial by fire to be able to do that. And if, we'll give you hints, but we won't hold your hand through it. Mostly because it's just really painful to help newbie users there who don't understand the complexities of building for iOS and actually trying that really complex scenario and then asking really questions where you literally need to teach them everything. So lots of people did it for Android, lots of people did it for Blackberry, lots of people did it for J2ME. For iOS, one guy did it that we know of and posted it in the forum. Other guys sent builds to the server, downloaded the resulting source code, and ran it in the debugger, because we do release the source code that we generate. Effectively, what we do in the server for iOS is generate this huge amount of code in C and in Objective-C that implements the whole thing in the native language, and you can just run it in Xcode. We actually use Xcode. We compile everything and sign everything and do that whole process. It takes a lot of time to do that. and it's expensive on the servers. But once we do that for you, we also give you the source code if you're a paying customer. $9, like I said, it's not for profit. And you just download it, and you can then run it and debug it. And the reason I know people did it is because they sent me bugs. Oh, yeah, in this and this line in C, just fix that. And you wouldn't know it unless you did that specific process. Obviously, you'll need a Mac for that. Part of the deal.
First, do you have a barcode component? And second,
Excellent.
do you have examples of apps that have been written by other people currently in the App Store or Play Store, etc.?
Okay. Less excellent question, but first one great. The barcode thing, we didn't implement barcode reading. And people asked us for it, so I just used the native interfaces and built a simple barcode demo that uses the native interfaces. It's based on Zixing, and it's really simple. It's one of our demos. You just use it and you get barcode scanning. It just works. And it uses native. We intend to incorporate that into our actual source tree when we have the energy to actually do that. Just a matter of tasks piling up. So we do have something there. The applications, there are a couple of applications in the iTunes Store, and that's pretty much it. Most of the applications go to Android and RIM and stuff like that, mostly because the applications are new and because you need to pay $100 for Apple. Because the platform is new, and because you need to pay $100 for Apple, which a lot of the developers that are more amateur that are there at the moment haven't done. So you need, those of you who don't know, you have to pay $100 per year for Apple to run on your own iPhone. That means you buy an iPhone, you can't actually run anything on it. It's not yours. Don't live under that illusion. It's only lent to you by Apple. It's not funny. It's really quite sad. That's the situation. So I hope I don't disillusion you in that regard, that building for the iPhone, you just take your iPhone, you plug it in, and it just works with that. You still need to pay $100 per year for them just to run a debug application, not to distribute it, just to run it on the device. That's not something we can control, unfortunately. It's Apple. Yeah. We use a garbage collector called Boehm. Technically, the VM that was not written by us, was written by you, I think, specifically, was used inside there. And it does the actual work of the bytecode translation. Am I correct, by the way? Yeah. Okay. So he wrote our iOS VM, by the way. Yeah. Like I said, lots of open source projects in there. Yeah. Mm-hmm.
Do you run bytecode in interpret mode, or do you do kit-style compilation for iOS?
It's technically AOT, but really the specific code that he generates is really, it looks more like a bytecode inside. You'll actually look at the code, it looks like a set of bytecodes. And just, instructions. And so it's more like an interpreter, even though it's translated. The code that's mission critical, the rendering portion, is handwritten by us. And that specific code is performant. You'll get the performance of a fast interpreter in terms of the Java pure code running on iOS. We intend to improve on that. The main issue I have with their specific implementation is both the performance and runtime, but also the translation time, which is really long. So when you send a build to iOS, you wait a lot longer than when you send a build for any other platform. So I want to shorten that process. Mm-hmm. Yeah. That's part of our higher level. That's the for-profit portion, where we actually charge much more for SLAs and stuff like that, guarantees, ability to install servers on your site, stuff like that. That's the enterprise class subscription. Yeah, we're going to make money off you, and we're willing to do so. Yeah.
If I have to write an application that interacts with the mobile phone's Bluetooth API and communicates with another device, can I do that? Can I create that?
Bluetooth is in our pipeline to do relatively soon. We haven't yet issued a Bluetooth. Again, the native interfaces. That's an important one, technically, that we need to. We're prioritizing, obviously, based on requirements from you guys. So we hear stuff from enough guys, and they're banging on our heads and do that. We eventually break down. So but we're getting lots of these bangings from lots of people, so don't blame us. Some people have stronger fists. Yeah. I didn't hear that. Okay. Oh, it's huge. It's literally huge. But today, for instance, I sent a build. Most applications are 6 or 7 megabytes because we build both ARM6 and ARM7. But today I sent a build. I got a 20 megabyte application for a really, really small application. Turns out I used the leather theme, which is really, really rich. And then when I grabbed the photo of, essentially you need splash screens. We do that automatically for you. You're not really aware of that, but we do that seamlessly on the server side for you. And because of the richness of the theme, just getting a picture in the resolution of the iPad 3, both horizontal and vertical, each one was 4 megabytes in size because it couldn't get compressed enough. So sizes balloon. But on the other hand, relatively to the size of applications on iOS, it's no big deal. Like I said, we intend to improve that as we go along. Size will also improve as much together with the build speed when we get to that. And I'll talk to you afterwards. I have some constructive criticism, shall we say. Anyway, we're finished, right? Okay, thank you all.